Hello, hope you are doing well. I'm Hemang Davé. Let's talk about machine learning at the edge. I'm sure you're equally passionate about machine learning and edge computing, just like I am. As part of the conversation, we will define what it means to say edge computing. We will discuss some important aspects of machine learning at the edge. And towards the end, we'll talk about forward-looking technologies which will aid machine learning at the edge. Traditionally, most of the compute, data, storage, network were housed in data centers. These data centers were owned by either private companies, universities, governments, and other entities. But as smart devices like iPhone and various other things started coming along, compute and data and other things have shifted away from traditional data centers. So what are some of the examples of things happening at the edge? I'm sure you have gone to grocery stores and have done self-checkouts. And if you ran into an issue, clerk working at that supermarket or grocery store would come in with a handheld scanner and help you scan things. That scanner is based on IoT, Internet of Things, and it's connected to some level of edge so that it can perform its functions. Traditionally, this kind of edge were kind of very small. They were put in on that storefront with 2 or 3 commodity servers, x86 based hardware, some storage, and with some network, it would connect to companies' data center, either on-prem data centers company owns or cloud data centers. In that specific scenario, that compute power, that storage, that network is rather limited. Usually, network connectivity is maybe 10 megabits per second or something along that line, comparing to data center connectivities, which are tens or hundreds gigabits per second. So this is very limited compute, very limited storage, and limited network. In that scenario, when this kind of edge interactions occur through the handheld scanners or various other devices, the compute and other parts are rather small, and that's why there is a good amount of latency. So while they can perform certain level of work, but their range of work is rather limited. In last 5 or 6 years, many connection providers as well as technology companies are setting up edge computing so that this kind of interactions become much, much faster than before. Now, edge cloud or 5G cloud, all those things are coming along, but the adoption is just at its infancy. So that's why it's very important for us to understand what kind of machine learning we can perform at the edge, because resources are still rather limited. So let's dive into some of the aspects of machine learning at the edge and what are some of the important things which we need to keep in mind. As we know, when we ever talk about machine learning, data is at the heart of that. So talk about data format. Traditionally, when you talked about data, it was very structured data, which was like 2 or 3 decades ago. And then we started having unstructured data, which is combinations of data, picture images, video images, streaming, various other things. So the data format has changed drastically. But here is the exciting or even scary part. As new devices come along at the edge, data format for next year or year after, we don't know. So our machine learning models need to be flexible enough so that they can accommodate data formats properly. Because you don't want to keep changing your models every time a format changes for data. Other thing is that, because the storage and compute and other resources are rather limited at the edge, you also need to consider relevancy of data. on what type of data you want to really run machine learning. Because if the device or devices connected to the edge are producing tremendous amount of data, for example, video footage, you don't need to be doing machine learning on everything out there. So to understand what are some of the relevant part of data you would want to do machine learning on. Other aspect of data is understanding both, in terms of relevancy, but also, are we doing something in real time, near real time, or are we going to look at it at some later point in time? In other words, that I don't need to be doing machine learning right now. But if we are doing real time or near real time machine learning, there is a reason for that, because we are looking for some level of insights which machine learning would provide us. And when we are doing something real time or near real time machine learning, it needs to be infused with level of automation such that these insights are acted upon. One of the favorite things I love to say is that insights are useless unless you act on them. So it's very relevant and important for us to understand how we are running machine learning on the data which is being produced. Other very important part as it relates to data is context computing, and it's becoming more and more integral part of machine learning as time moves on. So what is context computing? Let me give you an example. Say if you are driving your car and you want to go and make a left turn. So you are going to come to a traffic light. You will turn on your signal indicating that you want to make a left turn. Wait for light to turn green or wait for you to make the turn safely. You will make the turn. At that point in time, from your brain's muscle memory, you are retrieving a lot of data to act on things, which is making a left turn. And then you will make the left turn and you continue driving. Brain is very incredibly sophisticated things which we are given. And right after you make that left turn, you will no longer remember that specific left turn. Let me ask you, do you remember when was the last time you made a left turn? Chances are you don't recall that. Only time you will recall something where you made a left turn is if you saw an accident or something unusual, then your memory will keep that in your memory bank and brain would be able to remember that. But in most cases, we are not going to remember that. So context computing, as it relates to machine learning and specifically doing things at the edge, is extremely important. The reason is that we don't have enough resources like what we would have in traditional data centers. So context computing, understanding the data types, real time, near real time, all these things are equally important. Now, let's talk about some forward-looking thoughts when it comes to machine learning at the edge. So as I described that connection providers are coming up with their edge technologies so that they can provide you the compute, the storage, the network, and all these other things much closer to where the edge is. But there is also a very important example for us to kind of keep in mind is human brain. Human brain is an extraordinary example of something happening at the edge. We make decisions without being connected to many things. And by using brain as an example, some companies like Intel, IBM, and a couple others are coming with something called neuromorphic chip. Neuromorphic chip is creating unprecedented level of AI and machine learning at a fraction or even less than consumption of power. Because as you know, in traditional data centers, for us to be running machine learning and AI, it consumes millions of watts of power to do just those things. At the edge, we may not have that level of compute, that level of electricity to go and do those things. These neuromorphic chips run in the ranges of kilowatt hours, not megawatt hours. And this will help us create machine learning at the edge much more effectively and efficiently as we see it. Now, let me pause for a second and give you a chance to ponder on this question. Do you know on average how much electricity or electricity equivalent energy human brain consumes? Think about it. And also think about what kind of things, decisions and insights which we derive from using our brains. So the answer is roughly 20 watt worth of electricity energy is consumed by human brain on average. That's phenomenal, the type of work which we do with our brains compared to what machine learning and AI which we do in our data centers. So this neuromorphic chip will allow us to do machine learning at the edge with fraction of using the power and various other things. And it will open up a great amount of new frontier for us to go and explore. There are going to be even additional advances in this type of technologies which will help us. Other important thing to keep in mind as part of forward-looking technology is that we need to develop machine learning models. Not only they themselves would be autonomous, but also they help us create things. It could be IoTs or any kind of robotics or various other things which turn into autonomous machines. Because not every single time we will have the luxury to be nearby a data center to do machine learning. What is a great example of autonomous things which allow us, with the aid of machine learning? Yes, Tesla cars are one example, but I would love to discuss one of the other things which is I'm really fascinated about. James Webb Telescope, which had a great amount of machine learning built in when NASA launched it a couple of years ago, and then earlier this year, it came into existence. James Webb Telescope is a million miles away from the Earth. And the scientists and the engineers and others at NASA and all the subcontractors they had were able to use machine learning to make James Webb Telescope fully functional million miles away. What an awesome example of machine learning at the edge. So we need to be mindful of creating this kind of machine learning models which allow us to be fully autonomous either on Earth or million miles away in the space. Last but not least, I would love for us to think about sustainability as a design point as part of our machine learning. I would hate to use this word, but we have been incredibly spoiled when it comes to all the compute resources. We tend to waste a lot of it. And by wasting a lot of those things, we also wind up wasting power and various other things, which is not a great thing for sustainability. So let's make sure we become very aware when we are building our machine learning models and keep sustainability as one of our design points. What do I really mean by sustainability as a design point? Say if you're writing an application. While without realizing, we can write an application which can do petabytes worth of data moving back and forth. Because remember, with video streaming and various other things, coming up with petabytes of data is a child's play. It's not a big thing, right? So when we are creating this level of movement of data across data centers and across devices and things like that, there is a huge amount of power consumption associated with that. As a humanity, we use up more than terawatt hours of electricity on yearly basis across our data centers across the globe. If we can write smart applications which are aware of that, if they are not being used, they can shut themselves down. Or if we just go and do the machine learning where the data is and not go and run a lot of networks back and forth from data perspective, it will help us save tremendous amount of electricity, which we use unnecessarily today. So let's make that as part of our design point. And these kind of things not only aid us from sustainability perspective, but help us design machine learning models which are very intelligent, they are autonomous. Also, related to all these things, when we make all these things autonomous, we bring in and promote great amount of safety. We don't need human beings to be in a harm's way for every task. Say that if you are a person who is working on an oil rig or other dangerous places, perhaps we can just have level of autonomy through machine learning and various other devices and remove human out of that equation and allow autonomous robots or various other things to go and perform those tasks. And many times it will be better than what humans can. Anyway, I hope you enjoyed conversation with me. I would love to hear your thoughts on what you are doing about machine learning, and specifically when it comes to the edge. My link, the best way to reach out to me is through LinkedIn. My handle is Hemang Davé 1. We will also link it on the website, as well as my Twitter handle is I_M_innovation. I'd love to hear from you. I'm sure we'll be coming up with great amount of exciting machine learning for the edge computing. Until I speak with you next time, I hope you make some great amount of breakthroughs. Take care.